It is indeed possible to connect a hot tub to a ground fault circuit interrupter, or GFCI, when a generator is in use. A GFCI functions by constantly monitoring the electrical current flowing through a circuit. If it detects even a slight difference between the amount of current leaving and the amount returning, it interprets this as a ground fault. In response, it quickly interrupts the circuit, typically within a fraction of a second, to prevent electrical shock. To connect a hot tub to a GFCI system that can be powered by a generator, the process generally involves several steps. Firstly, install a generator inlet. A generator inlet box should be installed on the exterior of the house. A dedicated circuit must then be run from this inlet to the GFCI location. Secondly, install a manual transfer switch. A manual transfer switch is essential. This switch allows you to choose the power source for the GFCI, switching between the main electrical panel and the generator. Thirdly, wire the GFCI. The GFCI must be correctly wired to either the generator inlet or the transfer switch, depending on the setup. Fourthly, wire the hot tub. Finally, connect the hot tub to the GFCI. When the generator activates and begins supplying power, you simply use the transfer switch to select the generator as the power source. With the generator providing power, the GFCI will continue to protect the hot tub against electrical faults, just as it would when powered by the main electrical panel. It is vitally important to ensure that the hot tub is properly grounded. Correct grounding is crucial for the safety of users and for the reliable operation of the GFCI. Grounding provides a safe path for fault current to return to the source, tripping the GFCI and preventing electrical shock. It's also important to regularly test the GFCI. Test the GFCI periodically, following the manufacturer's instructions. This ensures that the GFCI is functioning correctly and will trip in the event of a ground fault. Given the complexities and potential hazards involved in electrical work, it is highly recommended to consult with a licensed electrician. A qualified electrician can ensure the safe and compliant installation of the generator inlet, transfer switch, and GFCI connection, adhering to all applicable electrical codes. To elaborate on GFCI operation, a GFCI outlet or breaker works by measuring the imbalance of current. It contains a sensor that monitors the current flowing through the hot and neutral wires. In a properly functioning circuit, the current flowing through the hot wire should be equal to the current returning through the neutral wire. If there is a difference of just a few milliamperes, typically 4 to 6 milliamperes, the GFCI will trip, cutting off the power. This difference indicates that some of the current is leaking to ground, possibly through a person, which could cause an electrical shock. GFCI protection is often required in areas where water is present, such as bathrooms, kitchens, and outdoor locations like hot tub installations. This is because water can significantly increase the risk of electrical shock. The speed at which a GFCI trips is crucial. GFCIs are designed to trip very quickly, typically within 25 milliseconds, which is fast enough to prevent serious injury or death from electrical shock. This rapid response time is a key factor in their effectiveness as a safety device. There are two main types of GFCIs: outlets and circuit breakers. A GFCI outlet is installed in place of a standard electrical outlet and provides protection only for that outlet and any outlets wired downstream from it. A GFCI circuit breaker, on the other hand, replaces a standard circuit breaker in the electrical panel and provides protection for the entire circuit. For a hot tub installation, a GFCI circuit breaker is generally recommended, as it provides protection for all components of the hot tub circuit. When installing a generator inlet, it is essential to follow all local electrical codes and regulations. The inlet should be installed in a location that is easily accessible but protected from the elements. The wiring from the inlet to the transfer switch should be properly sized and installed in conduit to protect it from damage. The manual transfer switch is a critical component of the generator system. It prevents backfeeding of electricity onto the utility grid, which could be dangerous for utility workers and could also damage the generator. The transfer switch should be installed by a licensed electrician to ensure that it is properly wired and grounded. The wiring of the GFCI to the transfer switch should be done carefully, following the manufacturer's instructions and all applicable electrical codes. The GFCI should be installed in a weatherproof enclosure if it is located outdoors. The connection of the hot tub to the GFCI should also be done in accordance with electrical codes. The hot tub should be wired with appropriately sized conductors and should be properly grounded. All connections should be made in weatherproof enclosures to protect them from moisture. Regular testing of the GFCI is essential to ensure that it is functioning correctly. Most GFCIs have a test button that simulates a ground fault. When the test button is pressed, the GFCI should trip and cut off the power. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. It is also a good idea to periodically inspect the GFCI for any signs of damage, such as cracks or discoloration. If any damage is found, the GFCI should be replaced. Grounding is a critical safety measure for any electrical installation, but it is especially important for hot tubs. Grounding provides a low-resistance path for fault current to return to the source, which helps to trip the GFCI and prevent electrical shock. The grounding system should be properly installed and maintained to ensure that it is effective. The grounding conductor should be connected to a grounding electrode, such as a ground rod or metal water pipe that is in contact with the earth. The grounding conductor should also be connected to the metal frame of the hot tub. In addition to grounding, it is also important to follow all other safety precautions when using a hot tub. Never use electrical appliances near the hot tub, and always keep electrical cords away from the water. Never enter the hot tub during a thunderstorm, and always supervise children when they are using the hot tub. If you are unsure about any aspect of the hot tub installation or operation, consult with a licensed electrician. They can provide expert advice and ensure that the installation is safe and compliant with electrical codes. In summary, connecting a hot tub to a GFCI for generator use is possible, but requires careful planning, correct installation, and adherence to safety guidelines. Using a generator safely requires understanding the proper procedures and equipment. Firstly, never operate a generator indoors or in a partially enclosed space. Generators produce carbon monoxide, a deadly, odorless gas. Secondly, keep the generator dry. Operate it on a dry surface under an open canopy-like structure. Thirdly, before refueling, turn the generator off and let it cool down. Fuel spilled on hot engine parts can ignite. Fourthly, use the correct type of fuel as specified in the generator's manual. Fifthly, inspect the generator regularly for damage, such as frayed cords or loose connections. Sixthly, use heavy-duty, outdoor-rated extension cords that are properly sized for the load. Seventhly, never try to backfeed power into the electrical grid. This is extremely dangerous and illegal. Use a transfer switch instead. Eighthly, install carbon monoxide detectors in your home when using a generator. Ninthly, be aware of the noise level. Generators can be quite loud, so consider your neighbors. Tenthly, store fuel safely in approved containers away from living areas. Understanding the power requirements of your hot tub is essential. Refer to the hot tub's nameplate for voltage, amperage, and wattage information. This information will help you choose a generator with sufficient capacity. It is also important to consider the starting wattage of the hot tub's motor, which may be higher than the running wattage. A generator's capacity should exceed the hot tub's starting wattage to avoid overloading the generator. Electrical codes such as those from the National Electrical Code, or NEC, provide detailed requirements for electrical installations, including hot tubs and generators. These codes are designed to ensure safety and prevent electrical hazards. It is crucial to consult with a licensed electrician who is familiar with these codes to ensure that your installation is compliant. Some key NEC requirements for hot tubs include the following. Firstly, dedicated circuit. Hot tubs require a dedicated circuit that is not used for any other appliances or equipment. Secondly, GFCI protection. All hot tub circuits must be protected by a GFCI. Thirdly, equipotential bonding. All metal parts of the hot tub and surrounding area must be bonded together to create an equipotential plane, which helps to prevent electrical shock. Fourthly, wiring methods. The wiring methods used for hot tub circuits must be suitable for wet locations and must be protected from physical damage. Fifthly, disconnecting means. A disconnecting means, such as a circuit breaker or switch, must be located within sight of the hot tub to allow for easy shutoff of power in case of an emergency. When selecting a generator, consider the following factors. Firstly, power output. Choose a generator with sufficient power output to meet the hot tub's requirements, as well as any other appliances or equipment that you may want to run simultaneously. Secondly, fuel type. Generators are available in gasoline, propane, and diesel models. Choose a fuel type that is readily available and that meets your needs. Thirdly, runtime. Consider the runtime of the generator, which is the amount of time it can run on a full tank of fuel. Fourthly, noise level. Some generators are quieter than others. If noise is a concern, choose a generator with a low decibel rating. Fifthly, features. Some generators come with additional features, such as electric start, automatic voltage regulation, and remote monitoring. The transfer switch is a critical safety device that prevents backfeeding of electricity onto the utility grid. There are two main types of transfer switches: manual and automatic. A manual transfer switch requires you to manually switch the power source between the utility grid and the generator. An automatic transfer switch automatically switches the power source when the utility power fails. An automatic transfer switch is more convenient, but it is also more expensive. When installing a transfer switch, it is important to follow all manufacturers' instructions and electrical codes. The transfer switch should be installed by a licensed electrician to ensure that it is properly wired and grounded. Proper grounding is essential for the safe operation of a hot tub and a generator. Grounding provides a low resistance path for fault current to return to the source, which helps to trip the GFCI and prevent electrical shock. The grounding system should be properly installed and maintained to ensure that it is effective. The grounding conductor should be connected to a grounding electrode, such as a ground rod or a metal water pipe that is in contact with the earth. The grounding conductor should also be connected to the metal frame of the hot tub and the generator. In addition to grounding, equipotential bonding is also important for hot tubs. Equipotential bonding involves connecting all metal parts of the hot tub and surrounding area together to create an equipotential plane. This helps to prevent electrical shock by ensuring that all metal parts are at the same voltage potential. The equipotential bonding conductor should be connected to all metal parts of the hot tub, including the metal frame, the pump motor, and any metal piping. It should also be connected to any metal objects within reach of the hot tub, such as metal fences or handrails. Regular maintenance is essential for ensuring the safe and reliable operation of a hot tub and a generator. The hot tub should be cleaned regularly to prevent the buildup of dirt and debris. The water should be tested regularly to ensure that it is properly balanced. The filter should be cleaned or replaced regularly to maintain water quality. The generator should be inspected regularly for any signs of damage, such as frayed cords or loose connections. The oil should be changed regularly, and the air filter should be cleaned or replaced as needed. The spark plug should be inspected and replaced as needed. The fuel should be stored properly in approved containers. By following these safety precautions and maintenance tips, you can safely and reliably operate a hot tub with a generator. Always consult with a licensed electrician for any electrical work and follow all applicable electrical codes and regulations. For example, a 240 volts hot tub rated at 30 amps would need a generator capable of supplying at least 7,200 watts, plus additional capacity for starting surge and other appliances. Also consider the type of outlets the generator provides, ensuring compatibility with the hot tub's cord. Different types of generators will have varying total harmonic distortion, or THD. Sensitive electronic equipment requires a low THD, clean power source. The NEC covers the requirements for installing electrical equipment in dwellings to ensure safety, but always refer to your local regulations as well. This can involve local amendments that supersede or modify the NEC requirements. If a generator is supplying a dwelling through a transfer switch, 250.34 covers the grounding requirements. It covers separately derived systems for grounding in these cases. A qualified electrician would be familiar with these requirements. Regarding GFCI testing, a GFCI should be tested monthly. If it fails to trip, it should be replaced. The test button simulates a ground fault condition. It is also a good practice to inspect the GFCI receptacle for any physical damage. A ground fault is an unintentional electrical path between a source of current and ground. It can occur when insulation on a wire fails or when water comes into contact with the electrical components. GFCIs are designed to detect these ground faults and quickly interrupt the power supply to prevent electrical shock.